Good morning, students. Welcome to the Aryabhatta PU Science College. In the previous class, we have studied about the current density. What is current density? That we have studied. So now we are going to study the electrical conductivity and the relation between the current density and the conductivity of the material. So third field of this current electricity. Third field, third chapter, third field. So that is. Now we are going to this. Define electrical conductivity. So what is meant by electrical conductivity? In the previous class you have studied the resistivity. What is meant by resistivity? Resistance per unit length. For 1 meter of the wire, how much resistance is there? That is called resistivity. So in this define electrical conductivity, we are going to study the conductivity. So reciprocal of the electrical resistivity of material of a conductor is called conductivity. The reciprocal of the resistivity is rho, conductivity is sigma. So reciprocal of electrical resistivity of material of a conductor is called electrical conductivity. The reciprocal of electrical resistivity of material of a conductor is called electrical conductivity. The conductivity is denoted by that is sigma, resistivity Re or resistivity rho. R is rho. So R means resistivity. This is one is rho. So you remember these points. R and R same. So and remaining is sigma. Sigma is for conductivity. So sigma is equal to 1 by rho, where sigma is equal to conductivity, rho is equal to resistivity. So, and mention the relation between current density and conductivity. Current density is denoted by J. That is sigma is conductivity, E is electrical field. So J is equal to sigma E. J is equal to sigma E, where J is equal to current density, sigma is equal to conductivity, E is equal to electrical field. This derivation is there. J is equal to sigma E. How it comes? It in the next period I will explain the derivation of this. Now we have to this is for 1 mark or 2 marks question. This is and sigma, that is also we can explain this. So sigma, the electrical conductivity is the ratio of current density to the electrical field. So electrical conductivity is the ratio of current density to the electric field. So you see here, so sigma, you keep sigma as it is and transfer this E to the LHS, then it comes J divided by J. So J divided by E. So sigma is equal to J divided by E. So it is the ratio of current density to the electrical field. Ratio divided by means ratio. So conductivity is the ratio of current density to the electric field. So that is. So here it is. Next one is drift velocity. Drift velocity, it is very important question. It is asked in several times. July 14th, March 18th, model question paper 2021. It is asked here. So next is also very important. So in the 2021 examination not conducted due to the corona. So this same question paper is comes to the next 21-22 years. So very important question is there. So define drift velocity. So the average velocity of free electrons in the conductor in the opposite direction of the externally applied electrical field is called drift velocity. Drift velocity, you say here, this is a metal. Here the electrons are there. So in the conductor, free electrons are there. If we apply the externally electrical field, electrical field is applied to this metal. So then what happens? Here electrons are there. This is a positive charge. This is a negative charge. Electrons drift towards the positive plate. Here electrons are moving towards the positive plates. When an electrical field is applied, the electrons trying to drift in the opposite direction of this. So what is this is the opposite direction. This is called the mobility of the that is drift velocity. drift velocity means Vd. So Vd is the drift velocity. Vd is the drift velocity. Drift, dm is drift, vn means velocity. So drift velocity is the electron moving in the opposite direction in the externally electrical field. So drift velocity is the velocity which is in the opposite direction when external electric field is applied. So it is the average velocity of free electrons in the conductor in the opposite direction of externally applied electrical field is called drift velocity. So the average velocity of free electrons in the conductor in the opposite direction of the externally applied electrical field is called drift velocity. Drift means it is dragging, then moving. So here electric field is there. It is we try to move this electron in the opposite direction towards the negative plate. So that is drifting. So when you apply applying this electrical field, it is the velocity, how much velocity is there to bring this in the opposite direction, that is called drift velocity. Average velocity of free electrons in the conductor in the opposite direction of the externally applied electric field is called drift velocity or drift speed. So that is. Then what is the average velocity of free electrons in metal at room temperature? At a room temperature, when it is no electrical field is applied, at room temperature it is 0. I have explained this same question in the previous class. Once again I am remembering in this. What is the effect of temperature on the drift speed of electron in a metallic conductor? What is the effect? When the temperature increases, then what happens? When temperature increases, drift speed also decreases. So drift speed decreases with increasing temperature. What is the effect of temperature on the drift speed of electron in a metallic conductor? So drift speed decreases with increasing temperature. Next, define relaxation time or mean free time. So what is meant by relaxation time? It is a collision of the so this is a metal, you see. This is a metal is there. This is a metal. So if the electrons are there, the atoms are in big size, electrons are in small size. Electrons are collide to this atom or electrons are collide to the electron. So collision takes place. Collision takes place between the electron and electron or electron and atom. So time duration, that is called the relaxation time. Relaxation means the time of this. Average time between two successive collisions of an electron with fixed atoms or ions in the conductor is called relaxation time. It is the average time between the two successive collisions. This is one collision and they come to this successive collision, this collision R. So what is the two successive collision? This is an electron, collision between this electron, two successive collision, the time interval. So that is called the average time between the two successive collision of an electron with a fixed atoms or ions in the conductor is called relaxation time. So that the average time between the two successive collision of an electron with fixed atoms or ions in the conductor is called relaxation time. It is two successive collisions. So it is two successive collisions. It is just, we can give an example. In a shuttle bat, the cork is once it is going to one side and comes to back side. So the time between this starting point and collision and next comes back to the original position, that is called relaxation time. So that is. Next, it is a model question paper 2021, very important question. What is the effect of relaxation time with the temperature of the electron? So what happens to the relaxation time with increasing temperature? Relaxation time decreases with increasing temperature. Very important. Note on this. Relaxation time decreases with increasing temperature. So what are the factors the drift velocity depends on? What are the factors that the drift velocity depends on? It depends on this electrical field. You see electrical field. It depends on the electrical field and relaxation time. So relaxation means collision between these. Relaxation time is that collision. So when the electron is moving, it is collided with the other metals or collided to the other electrons or nucleus also. So that is called a relaxation time. It depends on that relaxation time. What are the factors? The drift velocity depends, electric field in the conductor and relaxation time. So that define mobility of the electron, which is very, very important. March 14th, 17th, July 15th, 17th, a model question paper 2021. It is repeated several times. It is a continuous repeatable question. You note down this. This is defined as magnitude of the drift velocity to the electrical field. So mobility of the electron is represented by mu. So mobility of electron is the ratio of drift velocity to the unit electrical field. Unit electrical field is the mobility. The mobility of electron is defined as the magnitude of drift velocity per unit electric field. So that is mu is equal to electron mobility or mobility of electron mobility, both are same. So E is equal to electric field, Vd is equal to drift velocity. So mention the SI unit of mobility of electron or electron mobility, meter per volt per second. So meter square velocity is meter square per second. Meter square per second is the velocity. Electric field is volt. So meters per volt per second or meter square per volt per second is the SI unit. It is a repeated question. You note down this, underline this. J15, 17, March 14, 17. You have to repeat it. Continuous repeatable. Name the material whose resistivity decreases with increase in temperature. So there are some materials in which resistivity decreases with increase in temperature. Germanium and silicon semiconductor. You have some familiar experience in this. When the mobile is there, you see here, mobile is there. If you put the charging, for the charging, after the overcharge, the mobile automatically switched off. So in some sets it is there. So that is some semiconductors or germanium or silicon, those materials are used for the charger. So it is there. So that facility is there. In the refrigerator, in some time, 1 minute or 2 minutes, refrigerator is on, and when the temperature decreases, then automatically refrigerator become off, and sometime it is off, and then again it is automatically switched on and continuous to the working. So that is the resistivity decreases with increasing temperature. That is an example for this. So germanium and silicon are semiconductors. In burglar alarms, when the fire catches the building, automatically the burglar alarm starts alarming. So because when the temperature increases in the room, then automatically the circuit will be closed. So the circuit will on and it starts alarming. So those are all comes under these semiconductors. I will explain details in the next chapters. So that is semiconductors. That chapter is there. I will explain this. So name the material whose resistivity decreases with increase in temperature. So germanium, silicon and semiconductors, those are. How does the resistance of an insulator change with temperature? So that what I am explaining. The resistance of an insulator decreases with increase in temperature. So that is what I am explaining, given the example, burglar alarm. So what are the limitations of Ohm's law? Ohm's law, you see, says for Ohm's law there is a limitation. Ohm's law is not applicable to each and every materials. It is applicable to some ohmic devices. Some particular devices it is there. So what are the limitations of Ohm's law? Very important question, 2021 model question paper. So Ohm's law not applicable for very high and very low temperature. Ohm's law not applicable for very high and low temperature. It is not applicable to a certain that is electron tube and discharge tube. You see electron tube, tubelite, you know, in tubelite. So like V is equal to IR. When the voltage increases, current also increases. That is not applicable in electron tube, discharge tube and TV tube, doom TV, you know, in that it is not applicable. Even in LED, light emitting diode TV, LED bulbs, it is not applicable. So that is there. So Ohm's law not applicable for very high and very low temperature. It is not applicable for electron tube and discharge tube. So that is. What are ohmic and non-ohmic devices? July 17th. So it is very important question. So the ohmic devices means ammeter, voltmeter in conductors, like those are all ohmic devices. So devices which obey Ohm's law are called ohmic devices. You know, you see conductors, so voltmeter, ammeter. Voltmeter and ammeter you are seeing in the physics lab. Ohmmeter, ammeter, galvanometer, multimeters, like that. So devices which obey Ohm's law are called ohmic devices. Example, conductors, voltmeter, ammeter, etc. Devices which do not obey Ohm's law are called non-ohmic devices. Devices which do not obey Ohm's law are called non-ohmic devices. Electron tube, discharge tube, semiconductors, transistors. Transistor, you know, in the TV remote controller. TV remote controller works on the principle of these transistors. So that in that TV remote controller, Ohm's law will not applicable. So you see in the mobile phone, in all mobile phones, so mobile phone will the Ohm's law will not applicable for in mobile phone. So it comes under the semiconductors devices. So that is electron tube, discharge tube, semiconductors, transistors. These are given. These examples given in the textbook. But extra you want, mobile phone will not applicable for Ohm's law. So that is discharge tube. So those are all not iPad. Those are all not applicable under this Ohm's law. So that is they are non-ohmic devices. So there is. So ohmic and non-ohmic devices. Yes. Draw the graph of voltage and current graph for ohmic and non-ohmic devices materials. So it is comes in CET 15, NEET 18 exam. It is asked here. So this graph and some graphs are given. Which of the following graphs shows the ohmic devices? They are asked. So this here. So for ohmic devices, this means ammeter, voltmeter, conductors. So it is the voltage here. X-axis is voltage, y-axis is current. The VI graph, voltage current graph for ohmic material is a straight line passing through this origin. This is origin O. So this is passing through the origin. So this is for ohmic devices. For non-ohmic devices, voltage and current, this is origin O. So not passing through the origin. So VI graph for a non-ohmic devices is a curve. It is a curve or non-linear curve. It is for discharge tube, gas discharge tube, TV tube, tube light. That's it. And this is for semiconductors. Semiconductors, it is a straight line but not passing through the origin. So VI graph for a non-ohmic materials is a curve, non-linear or straight line not passing through the origin. It is a straight line not passing through the origin. For ohmic devices only, it is a straight line passing through the origin. So this is one. This is ohmic devices and non-ohmic devices. So all these you have to write it in a 15 questions. You have to write it in a notes. And what I have underlined here, you must underline these questions. Very, very important questions. If you want to get, if you got in between 40 and 50, you have to learn what I have underlined here. 50 above you want to score, what I have underlined, you have to read it. If one who want to get out of marks, all these questions you have to learn 100%. Within these questions, the examination annually in the annual examination, what I have written in the board, that questions only it will comes. So okay, and you have to read. One who want to get out of marks, all these questions you have to read and learn it. So next one is memorizing part. In the memorizing part, each and every answers I will explain 3 times. I will say in 3 times. By seeing one time and without seeing another time, you have to write it in a rough and send it to my WhatsApp number. So okay, next is memorizing part. Next is memorizing part. Each answers I will explain, I will say in 3 times, and each answer you have to write by seeing one time and without seeing another time in a rough. See, define electrical conductivity. The reciprocal of electrical resistivity of material of a conductor is called electrical conductivity. The reciprocal of electrical resistivity of material of a conductor is called electrical conductivity. The reciprocal of electrical resistivity of material of a conductor is called electrical conductivity. Sigma is equal to electrical conductivity, rho is equal to resistivity. And next one is mention the relation between electron current density and conductivity. So J is equal to sigma E. J is equal to sigma E. J is equal to sigma V. J is equal to current density. Sigma is equal to conductivity, E is equal to electric field. Electrical conductivity is the ratio of current density to the electric field. Electrical conductivity is the ratio of current density to the electric field. Electrical conductivity is the ratio of current density to the electric field. Define drift velocity. Average velocity of free electrons in the conductor in the opposite direction of the externally applied electric field is called drift velocity or drift speed. The average velocity of free electrons in the conductor. The average velocity of free electrons in the conductor. The average velocity of free electrons in the conductor in the opposite direction of the externally applied electric field. In the opposite direction of the externally applied electric field. In the opposite direction of the externally applied electric field is called drift velocity or drift speed. What is the average velocity of free electrons in the metal at 0 temperature? Is 0. What is the effect of temperature on the drift speed of electron in a metallic conductor? Drift speed decreases with increasing temperature. Drift speed decreases with increasing temperature. Drift speed decreases with increasing temperature. Define relaxation time or mean free time. The average time between two successive collisions of an electron with fixed atoms or ions in the conductor is called relaxation time or mean free time. The average time between two successive collisions of an electron. The average time between two successive collisions of an electron. The average time between two successive collisions of an electron with fixed atoms or ions in the conductor. With fixed atoms or ions in the conductor. With fixed atoms or ions in the conductor is called relaxation time or mean free time. What is the effect of relaxation time with the temperature of the electron? Relaxation time decreases with increase in temperature. Relaxation time decreases with increase in temperature. Relaxation time decreases with increase in temperature. What are the factors the drift velocity depends? Electric field in the conductor. Electric field in the conductor. Electric field in the conductor. Relaxation time. Relaxation time. Define mobility of the electron. It is defined as the magnitude of drift velocity per unit electric field. Magnitude of drift velocity per unit electric field. Magnitude of drift velocity per unit electric field. Mu is equal to Vd by Ve. Mu is equal to electron mobility. E is equal to electric field. Vd is equal to drift velocity. SI unit of mobility of electron. Meter per volt per second. Meter square per volt per second. Meter square per volt per second. Name the material whose resistivity decreases with increase in temperature. Germanium and silicon semiconductors. Germanium, silicon semiconductors. Germanium, silicon semiconductors. How does the resistance of insulator change with temperature? Resistance of an insulator decreases with increase in temperature. The resistance of an insulator decreases with increase in temperature. The resistance of an insulator decreases with increase in temperature. What are the limitations of Ohm's law? Ohm's law not applicable for very high and very low temperature. Ohm's law not applicable for very high and very low temperature. Ohm's law not applicable for very high and very low temperature. It is not applicable to electron tube and discharge tube. It is not applicable to electron tube and discharge tube. It is not applicable to electron tube and discharge tube. What are ohmic and non-ohmic devices? Devices which obey Ohm's law are called ohmic devices. Devices which obey Ohm's law are called ohmic devices. Devices which obey Ohm's law are called ohmic devices. Conductors, voltmeter, ammeter. Devices which do not obey Ohm's law are called non-ohmic devices. Devices which do not obey Ohm's law are called non-ohmic devices. Devices which do not obey Ohm's law are called non-ohmic devices. Example: electron tube, discharge tube, semiconductors, transistors. This one. So draw this graph. By seeing one time, without seeing another time, you have to write it in a rough. These are graphs. So okay. What I am giving the instruction, you have to follow this. Definitely you get a high score. So okay, best of luck. Okay.